So likewise, if you want to lock say page 4, you just have to go and put a tick against page 4. If you want to lock this OTP, put a tick against OTP. So these lock bits are pretty straightforward. Just identify the page number and tick the corresponding lock bit and click on the right button. So these three lock pages, now 13, 14, 15, I can't unlock it because that's like a one-way go. There are three more interesting bits here, which is called the block locking. I have shown here as a BL. So block lock 10 to 15, so 15 to 10, block lock 9 to 4, and block lock OTP. So these bits are meant for locking the lock bits. So assume that you don't want anybody to lock from P10, 10, 11 and 12. So I can just set this bit to true, and if you click on your right, what basically this does is it will never let any application or user to change the lock conditions for this page 10, 11, 12 up to 15. So that's why it's called the block lock from 10 to 15. Similarly, assume that you don't want users to lock pages starting from 4 to 9, say starting from 4 to 9, you have to put a tick against that and click on a right. So let's try to do this for 15, 10 to 15. So put a tick and say right and update. So from this point onwards, so nobody can modify or lock or change the conditions of the lock bits for page number 10 to 15. In this case, I have got the 3 pages locked and these 3 unlocked, and nobody can lock it forever. So I can always go and modify page number 10. So likewise I can do for page number 11 and so on. So next I'm going to show you how to use OTP. The OTP values are stored in page number 3, and in order to modify this, you're going to use the section called OTP. The first part of this section, which is called byte 0, corresponds to the value stored in B0, and the byte 1 corresponds to value stored in B1. So likewise the byte 2 and byte 3. So on the top section here, after this, the byte 1 and colon, you see the current value of the OTP. So it's not safe to modify this page number 3 directly over here, because OTP has got a special feature which needs a careful thought before you modify. So just like the lock bits, these are once writable. So once you set this, the bit as 1, you cannot change it back to 0. So you can think of OTP as a kind of a 32 flags which you can set it to 1 as and when required. The best example is the travel card. I think it's the feature of OTP that makes Ultralight a best card for a travel card or any limited access control cards. So in order to change the bit, you just have to put a tick on the checkbox. Say for example, I'm going to make this as the byte 0 as 1 tick here, and you also see the value of the hex when this bit is ticked. It's 80 because this is 1 and the rest are zeros, which is hex 80. Then click on the right and confirm this box. It says return to OTP OK, and as you can see, the value of B0 is 80. So the best example is, assume that you want to create a travel card which allows somebody to use the card, say for example 10 times. So you can set all the bits and keep only the 10 tick box empty. So like this. So if you click on a write now, I'm going to set all these bits to 1 but keep only these 10 bits as zeros. So probably the later software, they can set these bits to 1, or you can use this to track how many times a user has used this card. So OTP is a very important feature, and you have to put a lot of thinking before you start using it. But keep in mind, once you write something to OTP, you cannot undo it. So back in the documentation, whatever I explained about Ultralight, you can now follow by reading the documentation. So for example, the log bytes are explained here, and later on the OTP bytes, it is given an example. So initially everything starts with zeros, then the first write you're setting these bits to 1, and the second write you're setting the remaining bits to 1, and so on. And after that you can see explanation about the data pages, which I'm sure is easy for you to understand after this tutorial. Okay.